It went black. Now it's back, right? Well, thanks very much, Jessica, for the invitation. And I wish I could be there in Cambridge, but instead I'm here in Chicago. So greetings from the Windy City. What I'm going to speak to today is the use of pleasure and satisfaction as predictors, both in terms of the mean and the intra-individual variability of future use of tobacco products, both cigarette and e-cigarette use. And I'll describe this in a two-stage modeling approach. So EMA data very more commonly collected I know in Europe it's often called experience sampling. It's kind of grew out of diary methods, and they all kind of fall under what you might consider intensive longitudinal data. So in data collection modalities like this, we get frequent reports from subjects on events and experiences of their daily life. That's the whole point of these kinds of studies. So we can get 30, 40, even hundreds of responses per subject collected over, say, a week, a month, or some time period like that. Of course, in the old days, we used to collect this by Palm Pilots or PDAs, electronic diaries. This is all moved to smartphones, more or less. And the idea in these kinds of studies is to capture particulars of experience in a way not possible with more traditional designs, to see how things actually happen over time. Now, the reports we often get in these kinds of studies, they could be time-based, they could follow some fixed schedule, they could be randomly triggered, they could be event-triggered. Today, I'm going to be focusing on event-triggered. So what we're going to look at is their mood when these individuals smoke a cigarette, when they use an e-cigarette product. So there'll be the event-triggered responses in this particular study I'm going to look at. Okay. So I went on to PubMed Central and I typed in ecological momentary assessment, and you can see the numbers of papers using this it's just exploding, right? Well, I remember presenting this once, and somebody said you can type in anything and you'll see this kind of pattern. So that was a challenge, right? So I typed in canonical correlation, same kind of pattern. Discriminant function analysis, same kind of pattern. So I was trying to think of old statistical methods that maybe haven't been used quite so much anymore. But it's true, you see this pattern for many things. However, my colleague Robin Mermelstein suggests I type this in, lobotomy. And you don't see that kind of pattern. After the 50s and 60s, it kind of died down. But there's a little bit of a blip in the 1970s. And I think that could be attributed to the movie One Flew Over the Cuckoo's Nest. Either that or the punk rock band the Ramones had a song called "I'm a Teenage Lobotomy." So I think those might have led to the the rise in the 70s of this, but since then it's clearly died down. All right, so the data are rich and they offer many modeling possibilities. We get person level variables, we have occasion level variables, and both of these might determine some kind of occasion level outcome that we're interested in. And often we look if there's influence of the context or the environment on subjects' responses. And we've seen, for example, in our own studies that subjects' responses vary quite a lot depending on whether they're alone, say, or with other people. And early on came to realize that having such dense data within subjects, we could look at not just the effects of covariance on means, which is quite common in multi-level and regression models, but we could also look at the effects on the within subject variance. And it's really great that this whole day conference, I think it's a whole day, is devoted to this topic. So to see why certain subjects are more stable and more erratic and what might influence that. And it kind of resonates with an article that was published in Biometrics now over 20 years ago by Ray Carroll with the provocative title, "Variances are not always nuisance parameters," right? No, they're very interesting. Okay. All right, so here's the study that I'm going to look at, and it's with my colleague Robin Mermelstein at University of Illinois, Chicago. It's an observational study, and what it focused on were what we refer to as dual users. These were individuals who were primarily combustible cigarette smokers, but they had experimented to some extent in use of e-cigarettes or vaping products. So they had done both of these. And the goal of this particular study was to look at patterns and predictors of potential changes in tobacco use patterns. So what we're kind of interested in seeing is, are there individuals who switch, say, from combustible to e-cigarettes, and what might predict that? That was one of the aims of the study. Now, there was a fair amount of measurement in this study. There was an EMA measurement week, and in that measurement week, they were randomly prompted several times a day over the course of the week, and they also engaged the device when they were smoking a cigarette and when they were using an e-cig. So these were these event-triggered responses that I'm going to focus on today. We look at the random prompts in other studies. Today, I'm going to focus on the event reports of their mood when they smoke a cigarette, when they use an e-cigarette. And what I want to relate it to is their biweekly reports of cigarette and e-cigarette use over about a year, data that was collected after EMA. Okay, so they have this EMA week, and then after that, we're getting biweekly reports, up to 26 per subject, of their use of cigarettes, of their use of e-cigarettes. And what we're interested here is connecting their mood responses during the EMA when they're using a cig, when they're using an e-cig. Does that relate to their subsequent use of these products? And again, both in terms of their mean levels of mood and their variability. Now, we also had some measurements at baseline, and I'll be using some of those variables as covariates. Now, the total sample in this data set was about 400. Here, I'm going to focus on 279 of those subjects that provided at least one cig and one e-cig event report during that first EMA week. Okay. All of these people had at least one subsequent biweekly cigarette and e-cigarette use. So really the primary criterion here is this one cig and one e-cig event report during the EMA week. Okay, so the question I'm going to get to is, are the mood responses from the EMA cigarette and e-cigarette events related to subsequent rates of use of these two kinds of tobacco products? Okay. So here I have a two-stage kind of model. So I'm going to be doing this in stages rather than as a joint model. Now, I know some of the people in the audience, Richard Parker, Jessica Barrett, have done joint models, and those kinds of models are clearly very nice, and I've done some of that too. But here we're going to do it in two stages. Okay, and I'll just explain a little about some of the differences there that occur. Okay. The outcome we're going to look at is satisfaction that they attributed to these cigarette and e-cigarette events during the EMA, okay, or the experience sampling. I should get more European, ESM, right? So they're answering these questions. How satisfying was the tobacco product used? How pleasurable was the tobacco product used? Both of these items were rated from 1 to 10. And then I just averaged these two items. They were rather highly correlated. And so in total, we've got almost 9,000 event reports from these 279 subjects. You can see about 2/3 of so were cigarette events, and about 1/3 or so were e-cigarette events. Okay. The average number of events we got for the subjects was about 32, but clearly different subjects had different numbers of events. Okay. Now, the modeling of this satisfaction during EMA, both in terms of mean and variability, what I'm going to use that for is to try to predict their daily cigarette and e-cigarette use from those post-EMA biweekly reports. So there, again, they gave these reports. There could be a maximum of 26 over the year, and they were rather good at responding. The mean number of reports was about 21 here. But again, numbers of observations are varied from subject to subject. So there we got a total of about 6,000 observations of each of these two products, cigarette and e-cigarette. So here, let me describe the equations for the stage 1 model. So here I'm going to be using a mixed effect location scale model of satisfaction attributed to the SIG and e-SIG events during EMA. Okay. And I'm going to use different Greek letters for my stage 1 and stage 2 models just to help distinguish these two stages. Okay. So here I have the satisfaction report from subject I at observation J. And what I'm going to fit is a random intercept and slope model. Let me call it a random intercept and slope model. So here we have the random subject intercept and their slope. And the slope is for the within subject effect of whether the occasion is an e-SIG or a cigarette event. Okay, so I have a binary indicator here for each report. Is it a cigarette event? Is it an e-cigarette event? And what I'm doing here in the regression modeling is separating the between subject effect and the within subject effect. So very commonly done in multi-level kinds of models. That's what I'm doing here. And I'm going to have a random effect for the within subject effect. Okay, so here I have two what I call location random effects, an intercept and a slope. And I'll describe what those are in just a second. And I do a similar kind of modeling for the within subject variability. Okay. Here it's an exponential function to ensure that the resulting variance is positive. Okay. And here I have the within effect of whether the event is e-SIG or SIG. And I have the between effect as well. And here I have the scale random effect. Okay, so there's a total of 3 random effects here in the stage 1 model. Okay. So again, e-SIG was this indicator variable. I take the mean of that, that's the between effect of e-SIG. I take the deviation, that's the within effect. Okay. And so here, alpha 1 and tau 1 represent the within subject effects of e-SIG. When they're using an e-SIG, is their mean, is their variability different than when reported as a cigarette event? Likewise, alpha 2 and tau 2 are between subject effects. Is it the case that subjects who use more e-SIGs relative to other subjects who don't use as much, is their average mean satisfaction different? Is their average variability different? Now, the 3 random effects I have here, I have the intercept. So that's the satisfaction that they attribute for the cigarette events. I have the slope. That's the satisfaction for their e-cigarette events relative to the cigarette events. And then I have the variability in these satisfaction events. Now, I also tried to separate that variability for the SIGs and the e-SIGs. But what I found is that that was very, very strongly correlated. So I only have the one variability, which really is for both kinds of event reports. Now, in the software program, these random effects are standardized via the Koleski factorization. And so what I'm going to denote in my stage 2 model as the random effects is theta. These are independent standardized random effects. Now, in doing the estimation, this is all done by maximum likelihood. It uses adaptive Gauss-Hermite quadrature to integrate over the random effect. The benefit of this is that the missing data here are assumed missing at random, not missing completely at random, because this is full likelihood estimation. Now here shows a little plot of what I have in mind. Here we have cigarette events, e-cigarette events, and here notice that the mean is depicted as being higher for the e-cigarette events, and also the variability is less for the e-cigarette events relative to the cigarette events. Okay, so those are the fixed effects essentially of the model, but I have 3 random effects. Subjects differ in terms of their cigarette mean on satisfaction, here and here. They differ in terms of their slopes, and they differ in terms of their scale, their consistency, lability of their satisfaction reports. So this person on top, the red person, more variable, person in blue, less variable. Okay, so that's a kind of a pictorial of what the model is getting at here. Okay. Now I also queried in PubMed mixed effect location scale model, and hey, this is going off the roof too. Although you'll see that the y-axis, the numbers aren't in hundreds yet. We'll get there. All right, so what we want to use is these stage 1 random effects from the EMA data as predictors of stage 2 models of future outcomes. Again, the research question is, does EMA satisfaction, both in terms of mean and variability, predict future use of these tobacco products? Now, one thing to realize, random effect estimates are summaries of the EMA data from subjects. And so what people have done often in the literature is to use simple calculated statistics for this kind of idea. So calculate their mean, calculate their standard deviation, use those as predictors. Well, in spirit, that's similar to what I have here, but there's several advantages, I think, to the approach that I'm describing. For one, just using these simple calculated statistics, it doesn't recognize that subjects have different numbers of observations. So in other words, these calculated statistics are not of the same degree of precision. Also, doing it as calculated statistics, it assumes that these would be independent. Now, in my model, I'm allowing correlation among the random effects, so they're allowed to be dependent. But I think the real important aspect here is that if you just do these simple calculated statistics, you would be assuming that the missing EMA responses are missing completely at random. Whereas by using full likelihood estimation and what I've described, we're allowed to go to missing at random, which is a much less dubious assumption. So we've done some simulations on this, and what we've seen is that using these simple calculated statistics can lead to biased results in predicting future outcomes. Random effect estimates help to correct for these issues and lead to relatively unbiased results. And we've put this all into this statistical program called MixWild, which stands for Mixed Models with Intensive Longitudinal Data. And if you're interested in trying this program out, we published it in Behavioral Research Methods, and I have a link on my website here where you can find that. It automates this two-stage modeling procedure that I'm describing this morning or this afternoon, depending where you are. Okay, so this is the MELS model that has multiple location random effects and one random scale effect. We're generalizing that as well to have multiple scale effects. And those can be used to feed in to a stage 2 regression model that could be a linear regression model, could be a logistic, and here that could be binary, ordinal, nominal. It could be a Poisson. And again, the stage 1 random effects can be used as predictors in these regression models. And you can include other regressors interactions. And we're also extending the stage 2 model, so it can be a multi-level model as well. Now, in doing this, what we're using is what's known as the plausible value replication idea from Mislevy in the psychometric literature. The random effects are estimates. They're actually the mean of the subject's posterior distribution. So what we've incorporated in the program is to sample from the posterior distribution repeatedly, run repeated runs of the stage 2 model, and then average results using Rubin's rules for pooling parameter estimates. Essentially, it's like multiple imputation is what we're doing here, using each subject's posterior distribution. Now, throughout everything, we're using maximum likelihood estimation with Gauss-Hermite quadrature. Stage 1 model builds upon a previous program I wrote called MixReg-LS. Stage 2 models use code that I used in the 90s, way back when I programmed MixReg, MixOr, MixNo, MixPreg. So everything's programmed in Fortran to make it fast. But that's all behind the scenes because we have a graphical user interface and it's available both for Windows and Mac versions. Okay. All right, enough advertising for a free software package. Let's get to the results. Here's the stage 1 modeling of satisfaction. Now, in terms of the means, we're not seeing anything really significant. The intercept is kind of high, meaning that their satisfaction ratings to both are rather high. Remember, it goes from 1 to 10. Okay. In terms of the random location effects, there's a great deal of subject heterogeneity, both in terms of their intercept and their slope. And those two things are negatively associated. So if their slope is greater, their satisfaction report to cigarettes is lower and vice versa. Now, in terms of the within subject variance, what we're seeing is that their reports for the e-cigarettes are actually leading to reduced within subject variance. Okay, so this is a log linear model here. And if we exponentiate that coefficient, we get a variance ratio interpretation. Namely, we're seeing a 10% reduction in the within subject variance for the events associated with e-cigs rather than the cigarettes. And the random effects, the random scale effect, highly significant. Okay, so we see this all the time. What it just means is subjects vary in terms of their heterogeneity or of their mood response. Some subjects are very stable, some people are more erratic. And those random scale effects are highly correlated with the location intercept and with the slope as well. So I think it's very important, even if you don't have interest in these covariances, to have them in a model, because they often come out to be highly significant. And if you don't have them, then you're saying that these things are independent, which clearly they typically are not. All right, so here I ran several stage 2 models just to try different things out. For one thing I did was I took averages of their daily cigarette rates. And so it just had one outcome for cigarette rates. I did the same thing for e-cigs, one outcome for that. I tried that and used multiple regression. What I'm going to show you today is where I'm going to use their longitudinal data of cigarette rates and e-cigarette rates using mixed or multi-level models here for their longitudinal data. Okay. We also did a multinomial logistic regression where we looked during the second EMA wave whether they continued to use e-cigs and cigs, and could the random effects from the first predict the second. Again, what I'm going to focus on here is what I have in bold, the longitudinal modeling. So here's the longitudinal models we did for these repeated measurements of their cigarette rate and their e-cigarette rate. Now, as you can imagine, those variables were somewhat skewed, so we took a square root transformation to help to normalize those. And here, what we're describing is, here we have essentially just a linear mixed model for the cigarette rate from the biweekly reports. We have a random intercept, we have a random time trend. Okay, this is going across 26 weeks. Now, some people might object, saying linear effect over 26 is rather simplistic. Very true. However, what we're interested here is, did they go up? Did they go down? Okay. We're not interested in modeling the time course so precisely. We're just interested in basically their movement. Did they increase cigarette use? Did they decrease cigarette use? Okay. Here I'll have some baseline covariates, and then here are the random effects from the stage 1 model here for both the in terms of the intercept and in terms of the time trend. Okay. Now, let me say a little bit about the timing variable. I centered it and scaled it to represent effects for 1 year. And so therefore, the intercept parameters represent grand means or averages over time. And the time effects here and these interactions represent yearly changes across this 26-week period. Now, I did a similar kind of model here for the e-cigarette use as well. Okay, so I'm going to have the random effects from the stage 1 model predicting these two longitudinal outcomes. Now, here's what I found when I looked at the linear mixed model for the cigarette rate responses across the 26-week. And here, again, using these plausible value replications, since these models go fast, I went kind of excessive and used 500 plausible value replications. Here are some of the covariates I included. I have year. So in overall, the cigarette rate went down across that year of measurement. Okay. Gender, females smoked a bit more than males. Age, older they were, more cigarette use. And then SIG NDSS, that's a measurement that was made at baseline, a measurement scale about their dependency. It's called the nicotine dependency subscale or something like that. If they were more dependent, they used more cigarettes in those 26 weeks. So controlling for those things, here are the effects of the random effects from the stage 1 modeling. For cigarette use, the only one that came out significantly was location 2. That's that slope. And what it's saying is that if they had higher e-cig satisfaction, okay, during the EMA, then there was lower overall cig use during that biweekly period. And that was a highly significant result. So kind of makes sense. If they reported greater satisfaction during EMA for e-cigs, then during the follow-up period, they're using less cigarettes. Okay. The other bullet point I have here is for this kind of marginal result. It's 0.104, not really significant, but what it tends to suggest is that higher cigarette satisfaction during EMA marginally associated with an increase, because this is the time trend. Okay. Unfortunately, here the scale did not come out in terms of the use of cigarettes. However, when I also modeled the e-cigarette rate use in that follow-up period, I did see some additional effects that I'll describe. Now here too, I controlled for the same covariates. Here, the time trend was not significant. There was no gender effect. Age was negative, meaning older individuals used less e-cigs. And here we also had a measurement of their dependency on e-cigs at baseline. So the more dependent they were, as measured by this NDSS scale, the more use of e-cigs they used. Okay, those are the covariates. Now here, in terms of the random effects from the stage 1, we're seeing 3 significant results. What we see is that higher cigarette satisfaction, okay, so that's location 1, that's the intercept, during the EMA, that's associated with lower over yearly trend in e-cig. So they reduced their e-cig during this 26-week period. There was an effect on the time trend. Okay. Location 2, that's the satisfaction reported for e-cig events relative to cig events during e-cig. If that was higher, they used more e-cigs during the follow-up period. And then finally, scale, kind of interesting. Here, what we're seeing, if there's lower variability in their satisfaction reports during the EMA, then what we saw is higher overall e-cig biweekly rates. Okay, so what we're seeing kind of in combination of these two things, if they're giving high e-cig satisfaction during EMA that's rather consistent, then we see higher overall e-cig biweekly rates. Okay. All right. So to summarize what I've described here, these 2-stage models allow the random effects from one model, and here I've described that in terms of an intercept, a slope, and a scale, to influence other outcomes. And so the research question we looked at was, do random effects based on data from EMA, cig, and e-cig events, do they relate to subsequent rates of use of these 2 kinds of tobacco products? And I looked at in terms of an average across the year, and then the slope across the year, the yearly change. And these were the notable results that I've highlighted. Higher satisfaction from cigarette events during EMA associated with higher yearly trends in cigarette use, lower yearly trends in e-cig use. Okay. So if they're getting good satisfaction from cigarettes, then we're kind of seeing, increase in cigarette use, decrease in e-cig use. We also saw that higher satisfaction from e-cig events during EMA was associated with higher average e-cig use in the follow-up period. And then finally, with regard to variability, thing that I was most interested in some ways, what it saw from this modeling was lower variability in satisfaction. So more consistency in these satisfaction ratings during EMA. That was associated with higher use of e-cig during the follow-up period. Now, as I mentioned, several people in the audience, I know Jessica Barrett, Richard Parker have done joint modeling and published on that, and that's great. That's also possible instead of this 2-stage approach. But in some ways, the 2-stage approach reduces to some degree the complexity in the modeling. So I think these are both commendable tools that one may use one or the other depending on what kind of data they have, research question. Again, I've described a little bit about the mixed wild program we've been working on, but of course, Bayesian methods are quite commonly used in these applications using WinBugs, JAGs, STAN, other programs. What I've described this morning or this afternoon, depending where you are, some of this was published recently in a paper. It's an EPUB at this point that was in nicotine and tobacco research, and worked on this with some of my colleagues at University of Illinois, most notably Robin Mermelstein, my longtime colleague there. Okay. So I think I'll stop there and allow, I think I go for another 5 minutes or so for questions. Is that right? I'm sure there's no questions since it was all crystal clear, but I'm happy to entertain any kind of questions you might have.